Hello there! We see our outer body every day, other people's skin every day, so many other people's skin every day. However, we often seem to overlook the outer body even though it is the most obvious part. But did you know that this very apparent and natural coat is way more complex than it actually seems? Phosphorus, radium, sodium, vanadium, PRaNaV Nr on your screen, and today, let's talk skin. So, the largest organ in your body, the skin. The skin varies in thickness across different parts of your body. I mean, the skin above your eyelids is definitely not the same thickness as the skin above your heels. If they are, then well, you have some serious problems. But on average, the thickness of the skin is about 2 millimeters. 3 layers of the skin give this thickness: the epidermis, the dermis, and the hypodermis. So let's go from top to bottom, learning about each layer of the skin. The epidermis is the thinnest but outermost layer of the skin. That's the layer of the skin that we all see and touch. That feels a bit weird. It is responsible for many functions. Now of course, any responsible aspect of the body can't handle all the work on its own. So the epidermis is split into 5 sublayers. This can be remembered by the acronym Clever Lizards Gather Small Bugs, setting for stratum corneum, lucidum, granulosum, spinosum, and basale. Now the dermis is again split into the papillary and reticular layers. But the hypodermis is just, yeah. So let's start by looking at the diagram of the epidermis that yours truly created. The stratum corneum is the outermost layer of the skin. Do remember that corneum in this case has no relation to cornea. Ow, ow, ow. Anyway, this is made up of corneocytes, which are really just dead keratinocytes. But what are keratinocytes anyway? Keratinocytes are cells, sites that produce keratin proteins. These proteins are unsung heroes, helping in the synthesis of hair, nails, and many other bodily functions. In fact, in other animals like fish, keratinocytes are what produce scales. The keratinocytes here become corneocytes that are essentially strong but dead keratinocytes that protect you from external harm. So if you're able to feel, hold, and scroll your phone to watch this video, then you might as well say a little thank you to your keratinocytes. Thanks bro, you got me. After that, we have the stratum lucidum, a thin, transparent, lucid layer of keratinocytes. Now I know you're probably wondering, what's this guy doing here? Remember, God never makes any part of our body useless. Except... I will cover its function, but let me move on to the next layer first. This will give you a better understanding of the lucidum. The third layer of the epidermis is the stratum granulosum. This also has keratinocytes in them, except these are living keratinocytes. At this point in time, we need to agree that every layer of the epidermis has keratinocytes, which you're going to understand in a while more. The keratinocytes in this layer has granules, as its name suggests. Granules in general are like little suitcases. It stores different substances depending on its location. For example, starch granules in the stroma of a chloroplast contain starch, and granules in granulocytes store enzymes which are used for the immune response. If you look at the structure of the stratum granulosum under the light microscope, you would realize how dense it looks. This is because there's a high concentration of keratin in the stratum granulosum. The granules contain something called the keratohyalin proteins, and specifically profilagrin, which is like glue which holds the different filaments of keratin together. Well, profilagrin itself isn't like glue, but it's a precursor to filagrin which kind of brings together and organizes these keratin filaments. Profilagrin is just one type of keratohyalin protein, but there are 2 more, loricrin and involucrin. These are like the Mia and Tia of the epidermis. But these are actual proteins that contribute to the skin's role as a barrier. So when there's not enough water, when the environment is dehydrated, these 2 proteins will interlock, and this causes a cross-link formation. This cross-link formation is held together tightly by filagrin, and this leads to the skin being a barrier. Now we understand that the keratinocytes in the granulosum are living and functioning, while the keratinocytes in the corneum are well, dead. But here's the thing, cells don't just die of cardiac arrest. These cells die a slow, painful death. So between the living and dead keratinocytes in the granulosum and the corneum, there is an intermediate called elidin, not to be confused with this guy. And this is where the stratum lucidum comes into play. The stratum lucidum contains elidin. By the name, you may think that this is a protein, but in reality, this is a stage where the keratinocytes are removed of their nucleus and dehydrated. I mean, think about it. The granulosum serves as a barrier, meaning no water can get through. This layer is mainly found in places where there is thick skin, like your heels, and provides more structural integrity. The stratum lucidum also reduces the friction between the two layers of the skin. Then below the stratum granulosum, we have the stratum spinosum. This is the thickest layer that you will see under the light microscope, and this is what makes your skin flexible. This layer contains, you guessed it, more keratinocytes, except they are much younger. And as you know, kids have as much self-control as pigeons. Reward season in Candy Crush, let's go! Kids these days. So they need to be held together by their babysitters, the desmosomes. Desmosomes act as an adhesive between the keratinocytes. There are also some dendritic cells here. Seems familiar? You're right, in my previous video about the immune system, I roughly mentioned how the skin acts as a first-line defense. In reality, this is how it works. The dendritic cells in your stratum spinosum engulf any foreign materials right then and there, just like how this guy is eating his stapler. Wonder why? The stratum basale is the bottommost layer of the epidermis and produces new skin cells. That's right, this is like the hospital where the keratinocytes are born. As seen from the diagrams here, this is a singular layer of cuboidal cells that help out in the synthesis of keratinocytes. At this point in time, we realize something. As we go further and further up in the epidermis, the keratinocytes become older and older. They are born in the stratum basale. The young keratinocytes then make the skin flexible and carry out their roles in the spinosum. Then they start flattening to form barriers and then get dehydrated and then die off in the corneum. You know how people shed skin? Ew! There's nothing to be disgusted about, this is natural. But yeah, it's real! These dead keratinocytes are shed off the skin all the time. So as new keratinocyte layers are synthesized by mitosis or cell division, the existing layers get bumped up and promoted to the next layer, until they are too old. Other than that, the stratum basale also contains melanocytes, responsible for the production of melanin, which, as some of you might know, gives our skin its color. The stratum basale and the stratum spinosum are together referred to as the Malpighian layer. Now, an interesting thing to note here is that skin color isn't defined by the concentration of melanocytes or melanin, but rather the size of each melanocyte. Moreover, this doesn't only apply to skin color but also applies to hair color. You know how people who are stressed are said to have white hair? That's true as well. You know, there's a very interesting connection between the stress hormone cortisol and melanin, which you're going to be covering in a future video, so do subscribe to stay tuned. Now we have the dermis layer. This is the most important layer of the skin and does the most work, distributed across two layers called the papillary and reticular dermis. Well, the papillary layer doesn't look this rectangular and it actually looks much more variegated, something like this. But for illustration purposes, I'm going to simplify the diagram into this rectangular slab. The papillary dermis is quite simple and is mainly made up of connective tissues, like collagen fibrils, elastin fibrils, and oxytocin fibrils. Collagen fibrils, and specifically the type 3 collagen fibrils, connect the tissues loosely to improve flexibility of the skin. Elastin fibrils contain the protein elastin, as you can see from its name, and improves the elasticity of the epidermis. But the interesting thing is, it's not the same as another very similarly named connective fiber, the elastic fibril. These fibrils contain proteins like fibrillin, and while it also improves the elasticity of the skin, it also provides structural integrity. They are organized by the third type of connective fiber called the oxytocin fibrils. Funny thing is that there are small little dents and protrusions in this layer of the skin, and the epidermis just kind of rides along. This results in protrusions in our epidermis, which have helped our ancestors with grip and our current generation to get through immigration when traveling between two countries. If you don't know what I'm saying, I'm referring to fingerprints. Then we have the reticular dermis. This is the bottom but most important layer of the dermis, as you can clearly see by its size. This layer contains your glands, your hair follicles, and some blood vessels that supply the rest of the skin with nutrients. The glands that we have here aren't like your thyroid glands or pancreas or whatever, because these are exocrine glands. The main two glands here are the sweat glands and sebaceous glands. The sweat glands produce, congratulations, yes, sweat. Your sebaceous glands, however, produce sebum, which is the gooey, oily stuff that lubricates your skin. In fact, have you ever noticed that the region around your nose is so oily at the end of the day that you're this close to starting a new McDonald's outlet with the amount of oil on your nose? Yeah, this is because the skin around your nose is populated with a high concentration of sebaceous glands. You know, if I could use all my sebaceous glands to construct my very own oil reserve, my net worth would be more than the GDP of Brunei. I want that too. Yeah, I don't know about that. But anyway, another very interesting observation is that when you wax yourself, it hurts so much. And this brings us to the next point about hair follicles, which are right above some blood vessels. So you are essentially ripping the strand of hair off of your hair follicle, which is connected to a bunch of vessels that supply your hair with nutrients. Yes, that's right, even your hair needs nutrients. Since this video is already so long, let's make it a bit longer and look at the structure of hair. You have the hair shaft, which is the exposed section of the hair, you know, the one you style, the one you cut, the one you get in trouble in school for when it's too long, yeah, that one. Then you have the hair follicle that keeps your hair in your skin instead of it flying around in the wind. We have the hair strand, which is the entire structure, but we have very important regions, the hair bulb and the hair matrix on the central and peripheral hair strand respectively. The hair bulb contains the hair papilla. This is a small structure as seen here. But remember, don't judge a book by its cover. It is small because it is one of the most important group of cells in this region. This region is made up of the mesenchymal stem cells. And as we all know, stem cells are like the precursors to all the different cells in our bodies. This specific type of stem cell is involved in the proliferation of many different types of cells, like connective tissues, fibroblasts, osteoblasts, and one of which is the dermopapilla cells. This group of cells interacts with the rapidly dividing keratinocytes in the hair matrix, this region, and this is what produces our hair. Interesting, right? The reticular dermis also has two types of connective fibrils, specifically the type 1 collagen fibrils, which resist the skin from tearing by increasing its tensile strength. It also contains elastin fibrils, but this is mainly used to maintain the elasticity of the skin in general. Remember the difference. The elastin in the papillary maintains the elasticity of the epidermis, while this maintains the elasticity of the skin in general. Besides, the reticular dermis also has nerve endings, and these are very important as they are consisted by the cutaneous receptors. Cutaneous refers to the skin. This is a group of receptors including the thermoreceptors for temperature, mechanoreceptors for movement, touch and pressure changes, and nociceptors for pain. Lastly, we have the hypodermis. This is the bottommost layer of the skin, which is why it's named hypo, bottom, of the dermis, skin. This is nothing very interesting. It's mainly made up of adipose tissues. Adipose tissues are stores of fats. So anyone who is, you know, a little plumpy has a lot of adipose tissues. Obviously, the fatty food you eat is assimilated and stored into these adipose tissues, but the carbohydrates in the food that people eat is converted to glucose, and excess glucose is converted to glycogen. If you eat too much carbs, the further extra glucose will be stored as adipose tissues in the hypodermis. I mean, it does provide insulation and stuff, but really just go do some jumping jacks and lose some weight. Also, I know how the diagrams show that the three divisions of the skin are about the same size, but in reality they are more like this. Look at the epidermis. That is how small it actually is. This is why we almost always bleed when our skin is pricked, scraped, or whatnot. We almost always get into our dermis layer and blood vessels. Click the link in the description below to learn about another role of the skin in the immune system. Hope this video made your day a little bit more meaningful, and of course, don't judge people based on the size of their melanocytes. Do consider liking and subscribing to show some support. Peace!